Hello, everyone. Hopefully you guys are all doing well. Welcome to section 1.4. Today what we're going to be going over is linear equations in two variables and functions. So section 1.3, let's refresh our memory here. On section 1.3, we talked about functions. We talked about domain and range. Okay, and then we saw piecewise functions as well. So the continuation is specifying in one type of function, and most importantly on a linear equations in two variables and functions. So what we're going to be doing is looking at different functions, and we'll start with the first set, which is linear equations in two variables. So a line contains the equation, the standard form of an equation of a line is represented by this formula here, ax plus by equals c, where a, b, and c are both non-zero, and c is a constant. So a, b are non-zero values, but c can be zero. So it says graph the equation and identify the x and y intercepts. So in order for us to graph the equation, we will be using the x and y intercepts. And we learned that last class. So hopefully, if we recall, to find the x-intercept, we let y equal 0, or in that case, it was f of x equals 0, our function. So in this case, we have y being 0. So it's going to be 3x minus 2 times 0 is equal to 6. So then I just get 3x equals 6. I solve by dividing both sides by 6 and I get 2. So my x-intercept is 2, 0. Similarly, to find the y-intercept, now x equals 0 for that equation. So it's 3 times 0 minus 2y equals 6. And now this variable will drop. And I have a negative 2y equals 6. If I divide both sides by a negative 2, what happens when I divide a positive and a negative? The negative dominates, so I get negative 3. So then my y-intercept is 0, negative 3. With these two pieces of information, I can go ahead and graph my equation. So my first point is 2, 0, which is right here. Let me go ahead and plot that in green. So that's 2, 0 right here. And then it's 0, negative 3. Like so. 0, negative 3. So 0, 1, 2, 3 right there. And now we always read a graph from left to right. So we know this is a line that's going to be passing through those 2 points. So we're going to go ahead and graph. And there it is. There is our line. So our domain is negative infinity to positive infinity. Remember, left and right. And the lowest point is also negative infinity to positive infinity. So it's always nice to go that extra mile, and I start identifying the domain and the range, which we talked about last class. Okay, so for this problem, they just asked to define the x, the y-intercept, and then graph. Now, how would we do that for number 2? So if I want to find the x-intercept, you let y equal to 0, but there is no y component. So then how do I find it? Well, in this case, there's no y-intercept. There's no y-intercept because there's not a y component. Sorry, there's no x, because that's what we're finding. So notice that when we're finding the x-intercept, we let y be 0, but there's no y component here. So that means x-intercepts, there's no x-intercept. There's no way that this graph will touch your x-axis. So then how do I find the y-intercept? That you let x be equal to 0. So this gives us 5 times 0 equals -10. So then in reality, you notice that 0 does not equal -10. So then there's no y-intercept. So here, how would you go about graphing this? The only way you would graph this would be at 5x equal -10, and then the only number that satisfies this equation is if I divide both sides by 5, I get x equal -2. So an x being -2, what does that tell me? So at x being -2, and then there's this line right here. So the only way that you'll have an x-intercept, the x-intercept would be at -2. And this point is necessarily true for this value. So when you're finding the x-intercept, you are looking for y being 0. There's no component. So then let's fix that, because we found x to be -2. So what does that tell me? That you want to solve for x. So 5x equal -10, x equals -2. And that's your x-intercept. Okay. So then the first thing we set y equals 0. There was not a y component. So we said there's no, but then what did we discover? Well, when we solve for it, we have a vertical line that corresponds to this equation. So then we said, okay, well, then there is an x-intercept. So what went wrong? So it's nice to come back and look at what happened. So when you're solving for x, you're also solving for the x-intercept when there is no y component. So let's write that down. So when the y doesn't exist, there is no y component, we solve for x. We solve for x, and that gives us our x-intercept. Sorry, our x-intercept, correct. So let's go ahead and color this. Okay, so this one was kind of tricky. Same thing here. So now this one is just saying we only have a piece of information that's saying y equal 2. So that means that if my y value is 2, that means I'm right here. That means my x value. So y equal 2, this is my y-intercept. And then there's no x equals 0. So x equals 0 when y is equal to 2. So what happens when y is 0? There's no such thing as y being 0. So my equation is going to be actually a horizontal line at y equal 2. So then this is going to be my y-intercept, and this is my x-intercept. Okay. So there is my 3 equations. So I identified the x, the y-intercepts. So for the third one, we did not have a x-intercept, only a y-intercept, which is the case, in which you can get those 3 different cases. You can have both, you can have one, or you can have the other. So then what we're going to continue is talk about the slope of a line. So let's go ahead and define what the line slope is. So basically what the slope is the average rate of change between the change of y and the change of x. So this delta means the change in y over the change of x, where my denominator, of course, the subtraction between the two is non-zero. Because if it is 0, then we get something that's undefined, and we don't want that. So then, what is a slope, by the way? The slope is also defining the steepness of a line. How steep is it? The bigger the slope, the bigger the slope, okay? We can have positive slopes, negative slopes, and 0. So let's go ahead and talk about the slopes of the line. So find the slope of the line passing through the given point. So the first thing we want to do, remember when we were finding the distance, we were labeling points, and that's exactly what we're going to be doing right now. So then I'm going to label this as x1, y1, and this is x2, y2. Now I'm giving a formula where m defines the slope, which is y2 minus y1, the change of x over the change of y. And then, of course, I'm going to be substituting -8 as my y2 term minus a 3 from the y1 over x2, which is a 1 minus a minus 2. Always make sure that you are putting in there, when you have two negatives, a parenthesis in between, okay? Notation matters. So here I'm going to get a -11 over a 1 plus a 2. So 1 plus plus, so it's a -11 over 3. So this means I have a negative slope. That means my line is actually going downward. I have a downward slope. So the slope of this line is -11 over 3. Similarly, I'm going to go on to the next one. You begin by identifying what is x1, x2, y2. We follow our formula that says y2 minus y1 over x2 minus x1. M is equal to, the slope is 1.3 minus a negative 0.04 all over. Now my x2 is let me go back there a few minutes. Okay. Now it's a 0.8 minus a 1.2. So then when we clean it up, this is going to become a plus 1.7 over, and this should be a point, not a 0.04. Let me fix that. This is a 0.4. That's a negative 0.4. So the 0 is on the outside. So it's going to be 1.7. And then I'm going to get a negative . So then how do I solve this? Well, one way is I can move the decimal once, and I can convert this as -17 over 4, which is the same case. Okay, so that's a trick. Those placeholders, as if you were multiplying top and bottom by 10. So if I multiply top and bottom by 10, there it is. So you moved to 10th place, a -17 over 4. Can you leave it as a -1.7 over 0.4? Sure, but this one just looks cleaner. Okay, so all I did was multiply top and bottom by 10. And that's it. Okay, so that is our slope for number 5. Similarly, this one, 6 and 7, they don't give us points, but what do we know about a horizontal line of y equal 4? So when y equal 4, let's graph y equal 4. Let's start by graphing y equal 4. We know that y value, my x is going to be 0, but my y is going to be 4. That's a y-intercept. We know that. So we're going to go 1, 2, 3, 4, and then we're going to have a horizontal line. What happens Do you have any changes when you are a horizontal line? Assuming that I'm standing right here. As I'm moving along, is there a change in y over a change in x? Well, is there a change of y? No, 0. Do I know a change in x? I don't know what that is. So technically, my slope, the slope of any horizontal line is equal to 0. The slope is 0. You can also select a point from here. So 1 second, you can select a point, let's say 0, 4, and then maybe 1, 4. 1, 4 is also on my graph. And then I can plot any point and I could say, okay, well, that's y2 minus y1 over x2 minus x1. How did I get 1, 4? Because it's a horizontal line. So my y value will always be 4, but my x can be anything. So I selected 0, 4, and 1, 4. I find the slope between those points and I get 4 minus 4 over 1 minus 0. So 0 over 1 is 0. So my slope is 0. I just proved that. Now what happens when I have a vertical line at x equal to -3? We begin by also graphing. If I'm going to go 1, 2, 3, and it's going to be now a vertical line downward. This is my x, this is my y. I know that this corresponds to x equal -3. So this point right here is -3, 0. And then up here, let's select a point, let's say -3, 1. Now these are my points. So I selected -3, 0. So it's going to be -3, 1, comma, -3, 0. So I'm going to say, okay, well, x1, y1, x2, y2, let's solve for our slope. M is equal to -3 minus a -3 over 0 minus 1. So my slope is going to be -3 plus 3 over -1. M is equal to, sorry about that, and this should be flipped. So let's not get ahead of ourselves here. So I have M to be y2 minus y1, so 0 minus 1 over, there it is, x1 and x2, -3 minus a -3 on the bottom by the formula. So then M is -1 over -3 plus 3. So what do I notice about -1 over 0? This is an undefined slope. Undefined because I have a 0 on the denominator. So whenever you have a vertical line, and let's write that in star, so the slope of any vertical line, this is undefined. Okay. So we're going to be talking about that in a moment. So we're going to be we're going to do a compilation of the slope. So if you have a positive slope, you're increasing, you have an increasing slope. So I'm going upward. If you have a negative slope, you're going downward. And how do you know when to go up or down? You always read the graph from left to right. So you always read from left to right. So this way, if you're starting high and then you're going low, that's a negative slope. But if you're going low, you're going up, then that's a positive slope. You have a y equal k, a constant, a horizontal line, you have a 0 slope. And then here, of course, your undefined slope and you have a vertical line. And we just showed that because you get a denominator of a 0 down there. Okay. So hopefully as we're speaking and as we're drawing, we get to see a visual, but we also get to also substitute points. And you'll have a Canvas activity where you are also going to be exploring different graphs and how to find different slopes of points. You're gonna be graphing points. So you're gonna have a nice visual as an additional resource, for sure. And also you're gonna be seeing this in your homework, so making sure that we understand how to do that. Now let's go ahead and talk about the slope intercept. So what we did on the first section of this lecture was we saw the standard form. So the standard form of a line was defined as ax plus by equals c. Now we're going to learn a new format that's called the slope-intercept form of a line. And what is so special about it? You can write an equation with that information. Once you know the slope and the y-intercept, you are allowed to write an equation in that format. So then how would we know how to find the slope and the y-intercept? Well, first of all, notice that we want to convert this into y equal mx plus b. That's our goal from here to here. Now, one of the ways that we can do that is noticing that on this form, the y is isolated, which is not the case for 3y minus 2x equal negative 6. So what we want to do first is actually isolate y from 3y minus 2x equal negative 6. So to do that, I'm actually going to start by bringing the 2x over. So then I'm going to have a 3y equal positive 2x because I moved it by adding a minus 6 because the 6 doesn't change. Now there's one more thing that I have to do to leave the y by itself. That means I have to divide everything by a 3. So I get y equal 2 over 3x minus 2. Okay, this looks a lot like y equal mx plus b, is it not? If I put them lined up together, I can easily identify that m is 2/3 my slope, which is also called rise or run. And then b, my y-intercept, is 2, negative 2. So then it's 0, negative 2. So from this piece, I know the y-intercept and I know my slope. I can graph the line given the slope and a y-intercept. So how do we do that? Step 1, when we graph, plot the y-intercept. So my y-intercept is 0, negative 2. And where did we get that from? From solving. Here it is. So b is equal to negative 2. So then we start right here at 0, negative 2. Now what happens after we plot the y-intercept? Step 2, we follow our slope. Our slope m to be equal to 2/3. What does that mean? That means I'm going to go up or rise 2 units, and I'm going to run 3 units to the right side. So up 2, run 3. So up 2 and then run 3. 1, 2, 3. There's my other point. So this point is 3, 0. And then from this point, again, I keep on following my slope. Now I'm going to go 1, 1, 2. So let me use a different. So I'm going to do 1, 2, rise 2, run 1, 2, 3. Again, run 2, run 3. So that would be my other point. That looks like 6, 2. And then there's my line. See how I'm following my slope? 2, 3, 2, 3, 2, 3, and so on and so forth. So rise, run, rise, run, rise, and run. It's always going to be that case for this one. Now we're going to do the same thing we did here for the next one. Again, our goal is to convert this. Notice that the y is not isolated. So I have x equal negative 2y plus 4. So how can I isolate it? There's two ways I could go about it. I could bring the 2y over or the 4 over, whichever one you like. I'm going to move the 4 over by subtracting 4, and then I have a negative 2y. Now I want to solve for y, so that means I divide it by -2, divide by -2, divide by -2, or multiply by negative a half, whichever one. It's the same. So here I have a -1/2 x, a positive 2 equals a y. Oh, this looks a lot like y equal mx plus b. So if we line them up to each other, my slope, m, is equal to -1/2. That means now it's going to go down 1 and run 2. And my y-intercept is 0, 2. So again, we start graphing by plotting my y-intercept. And then let me change it to this one. From this point, 0, 2, we're going to go, I'm going to follow my slope. So again, step 1 was plotting the y-intercept. Step 2, I have to follow the slope, which in this case is -1/2. That means you're going to go down 1 unit because it's negative. Why am I going down on this part, which I didn't do because of the negative? So I can go down 1. I'm going to use a different color. Down 1. And I don't know why it doesn't let me do that. So I'll just go down 1, run 2. So there's my point. That point corresponds to 2, 1. And then I'm going to go again. Down 1, run 2. That point corresponds to 4, 0. So then I could go down 1 over 2. So there's another point. So then here, notice that my slope now is going down. This is a negative slope right there. So here we had a positive slope because I have a positive slope, it's going upward. And here we have a negative slope, it's going downward. Because it starts from the left. So see how it's from left to right, from left to right. Good. Okay, so hopefully as we're practicing, we're getting an idea of how it looks like. It's pretty self-explanatory. Once we start solving for y, we line them up together and we can easily define what is the slope and what is the y-intercept. Now that we know those pieces, I want to actually write an equation in slope-intercept form. So in order for me to, what is, before anything, what is the slope-intercept form? That's y equal mx plus b. And what is this telling me? It's saying it's passing through the point and it has a slope of 5. So we know that m is equal to 5, and the point y1, we know one of the points. So one of the points is -2, 3. So what are we not given? The only thing that we're not given is the y-intercept. So the thing is that we can actually find it by graphing the equation here, graphing what we know. So we know that there is a point at -2, 3. So I'm going to go -2, +3. And so this point is -2, 3. And then I know that my slope is 5. So I'm going to go up 5 over 1, up 5 over 1. So let me do this a little bit bigger. I'm actually going to go that direction. So this is my x and this is my y. So I'm going to begin by doing -2, +3. And then from here, I'm gonna go, okay. I'm gonna go up 5. So that should be at 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Up 5 over 1 because my slope is 5. So I'm going to need a little bit more tick marks. So let me just go ahead and do that. Let me go ahead and open Desmos because I want to share how that looks like in a bigger screen. As I don't have a lot of room. So this is one of the techniques that is always helpful to just have your visuals. So I'm going to start with my plotting my point -2, 3 right there. Now from here, I'm going to say, okay, I want to go up 5. So I'm going to use, let's say this point. I'm going to use an annotation. And then I'm going to do I'm not sure if I could do a text. No, it's not letting me do a text. Okay. I want to be able to, what's the dock bar? That's okay. From here, I'm going to go up 5. So from this point, up 5. So let me label. I'm going to go up 5. So it's 1, 2, 3, 4, 5, and then 1. So there's my other point at 1, 8. Sorry. -1, 8. How did I get -1, 8? So notice that I went up 5 over 1 because the slope, so my m is equal to 5 over 1. My slope is 5. So 5 is 5 over 1. Rise, run, rise 1. So notice that it's rise 5, 1. Now from here, I need to rise again. So if I'm rising 5 again, now I'll be at 13. So up 5 from 8. 1, 2, 3, 4, 5. And then right here, my other point would be 0, 13. So then if I collect, so up 5 over 1, up 5 over 1, up 5 over 1, let me label. And I want to be able to connect the dots. So then I know that my y-intercept is at my b is equal to 13. So I know it's going to be 5x plus 13, my equation. So if I have y equal 5x plus 13, there it is. How did I get the correct answers? Well, remember, my equation is y equal mx plus b. I knew for a fact that m was equal to, so this is b, I don't want to slide that one. I know that b is 13. I know that for a fact. So then my slope, if b is 13, and I know one of the points, your slope is 5, up 5 over 1, up 5 over 1, up 5 over 1. I found my y-intercept. So to graph any equation or to write your equation, let me go back to my graph right here. So when we used Desmos, when we used our Desmos activity, so on Desmos, we saw that your x was 0 and my y was 13. This is the y-intercept, which corresponds to b. And I already knew that my slope was 5. So given the slope and the y-intercept, I can go ahead and plot that formula, that equation. So it's y equal mx plus b, but you already know m is 5. The x goes for the right plus the y-intercept, which was a 13. And this is the equation that we got from the point and the slope. And how did we do that? By graphing. Graphing and following the slope. Up 5 over 1, up 5 over 1. So then the slope was 5 over 1. So rise 5, run 1 from your point -2, 3. Okay. All right. So hopefully that made sense. Of course, I'm always here to answer questions if you have them. If you're having issues with Desmos, understanding anything, please come to my office hours, which are every Friday from 9 to 10 via Zoom. So please make sure that you're reaching out with your questions. I'm also available through discussion post or through Canvas inbox. Okay. Alrighty. So let's compute the average rate of change. What really the average rate of change is actually what your slope is. And it's also interpreted as f of x of 2 as a point divided by x of 2 minus x of 1. Remember this f of x of 1 and f of x of 2. These are just your y values. Okay, so your average rate of change, you're actually looking for the slope of a secant line. If you have, let's say, a function, and you're trying to find the average rate of change, you're finding the slope between 2 points. So the first thing that you want to do is locate what average rate of change between what 2 points. So I'm looking at this point and at this point. I want to find the line of that slope. What is the average rate of change? What is the slope? Well, we'll notice, first of all, that's kind of going upward, the slope. So if I want to go from here to here, you know that there's going to be a positive slope here just by looking at the graph itself. Notice it's going up from left to right. So let's show that. So first it's x1, y1, x2, y2. So the first thing we want to say is, well, the slope m is y2 minus y1 over x2 minus x1. So here we have a 2 minus 0 over a 0 minus a negative 1.5. So 2 minus 0, there's a 2, and then this is a positive 1.5. So then 0, when we clean it up, assuming that if I want to multiply this or bring this over, what do we also know? We know that 1.5, so 2 over 1.5 is actually 3/2. So a division over a division, so it's 2 divided by 3 over 2. I don't know how to divide fractions, but I know how to multiply them. So it's 2 times 2 over 3 by properties of division. So 2 times 2 is a 4 over 3. So my slope is a positive 4/3. So if I would make a line like this, I would have a positive slope right there. So it would have something positive, which was 4/3. That was my slope of the line. Now, if I want to find the slope of the second one, which is what happens from here to here, notice that my line is actually going down. It's going to be negative, but we want to show that. So we begin by x1, y1, x2, y2. Follow my slope, which says, okay, well, my y2 minus y1 over x2 minus x1. The change of the change of y over the change of x. Notice that my line is going to go down, so we want to show it's negative. So what's y2? That's 1 minus a 2 over 2.5 minus 0. So we get negative 1 over 2.5. Now, similarly, I'm going to change 2.5 as 5 over 2. So it's negative 1 divided by 5 over 2 because that's 2.5. So that's negative 1 times 2 over 5. So it's negative 2 over 5, and that's my slope. And notice that if you make a line this way, you have a negative slope. Like so. And we show that, negative 2/5. So that means the average rate of change of a function that's not necessarily linear. you could still identify the slope of them. And they're called the slope of a secant line. Perfect. And then we're going to move on to the last section, which talks about graphing inequalities and or solving equations graphically, just looking at the graphs themselves. So here we have two different lines. So notice that the blue line corresponds to 0.5x plus 1, and then we have our red line. The red line that corresponds to 3x minus 4. So what happens, what does that mean when they're equal? When they're equal, that means, so when they have equality, means their intersection. Find the intersection. So when are they both x and y equal? They're both equal at the point 2, 2. So your solution is they are equal at the point x equal 2. So they are equal at the x equal 2, and we're always going to be looking at the x value. So now what happens if we are looking for 14? When is the blue line less than the red line? Which area? Now, if we look at, so is it more than 2, less than 2? So then we select a point, let's say 0, and we test 0 because it doesn't live in either or. So if we select 0, if we select x equals 0, we plug it in and we say, well, 0 plus 1, is that less than 3 times 0 minus 4? And then we say 1 less than negative 4. Is that true? No. So then we are not going to be shading my 0 on this side. So is the blue less than the red in this area? No, it's actually going to be less than at the other area. So on the other side. It has to be 2 or more. So then here, your blue line is less than the red after 2, so greater than 2. So then at x greater than 2. So if I have, let's say that x is 3, and then I have 3 here, or let's say 5, let's pick any value greater than. So let's say I pick 10. So 10 times 0.5 plus 1, is that less than 3 times 10 minus 4? So then I have 2, sorry. What's half of 10? That's 5. 5 plus 1 is 6. Is that less than 30 minus 4, which is 26? Yes, that's true. So everything here is true. So only when x is greater than 2, your blue line is less than the red. So then my answer would be from 2 to infinity. That's where your blue line is less than your red line. Now, what about when is it greater than or equal to? Well, it's greater than or equal to when, let's suppose that we plug in a 0. So again, test 0. So then x is equal to 0, plug it in. So I get 0.5 times 0 plus 1. Is that greater than or equal to 3 times 0 minus 4? Well, then here you'll say, well, 1, is that greater than or equal to negative 4? Yes. It's greater than, definitely. So we know that we are going to be graphing or coloring. So the blue is going to be greater than or equal to the red when we're shading up here where the 0 is on the red. So it's going to be equal to 2. So then x is being less than or equal to negative, x are equal to positive 2. And then you'll have this color down here. It's true, right? You're shading wherever your 0 is. Down here. So then your answer will be from negative infinity to 2, inclusive. Okay, and it's always nice to look at your graphs and your shading. So let's go back to our shading. The first part, we noticed that we're not going to be shading where the 0 is because it's not true. So we're going to shade upward. That means that x has to be strictly greater than 2 in order for the inequality to suffice. Now, when we did that for 15, we said, yes, that's true. So we want to shade in the orientation where 0, 0 is on this graph. So then that means that x is less than or equal to 2 will suffice this inequality, this blue. That's when your blue is greater than your red. Okay? And they're equal when they're intersecting. And then, of course, there's going to be more activities where you can shade in Desmos and also be plotting points. So it's going to be a combination for a Canvas activity. So please make sure you review, you look at your lecture notes, and you are also participating in class discussions. And if you have any questions, by all means, come to my office hours or shoot me an email. I'm happy to help. Thank you so much, and I'll see you on the next video.